how far is the commute? So the Research Triangle is a region in North Carolina that is anchored by 3 major research universities: North Carolina State University, Duke University, and the University of North Carolina. Okay. The 2019 census recorded a population of 2,079,687 for this region. So one professor from UNC drives 9.8 miles to give a symposium at Duke in the morning. Okay. So he drives from UNC to where? Which one of these? Duke? Yes. So he's driving how far? Oops. 9.8 here, yes. So 9.8. He then turns and drives 23.9 miles to give the same talk at NCSU. So he's going to drive 23.9 miles here. Okay. The 2 roads make a 100-degree angle. So where's my angle here, the measurement here? Oops. It's going to be a measure of what? 100 degrees there. Okay. Use the law of sines or law of cosines to determine how far he will have to drive to get from NCSU back to UNC. So what am I looking for here? I'm looking for this distance here, right? I'm looking for that x. So am I going to use law of sines or am I going to use law of cosines? Cosines, okay? Because I have a side, included angle, and the other side. Okay? So we will say what? X squared is going to be equal to 9.8 squared plus 23.9 squared minus 2 times 9.8 times 23.9 times cosine of that angle, 100 degrees. All right. So what did you get for x here? 27.4. Okay. Make sure that you're in what mode? Degree mode. Okay. So 9.8 squared plus 23.9 squared minus 2 times 9.8 times 23.9 times cosine of 100 gives you what? 748.59, and then we'll take the square root of that value, which is 27.36. Okay, so check Google Maps to find the shortest distance between NCSU and UNC. So, did y'all do that? Okay, what did y'all get? How much? 25. Okay, so 25.9. Okay. So the shortest distance in Google Maps was 25.9. Okay, so how does this distance compare to your answer here?
It's pretty close.
It's pretty close, but it's a little bit, what, shorter? A little less, right? Okay. What do you think might cause the difference?
It's not like a straight shot for that.
Yeah, right. It's probably like a curved road somewhere, right? So it's not like we're going straight. Okay, good deal. Find the angles made at the University of North Carolina and North Carolina State University. Okay, so if I want to find these angles, I want to use, of course, you can use law of cosines again and again, right? But you could, let's do this. Let's label these so that we can let's make that C right there. So that's C. So this will be angle C. I don't know, let's label this A and this is B so that we can kind of know our sides. Okay, so we use law of cosines to find the other opposite side over here. So law of cosines gave us this is 27.4 miles. So 27.4. So which one of these angles would I find next? Okay, so one that's across from the smallest side, right? So that would be angle what? A. Perfect. So let's find angle A, which is going to be the angle that is formed at NC State. So North Carolina State University. So that's angle A. Okay, so what am I going to do? I'll do sine of angle A over, what is that, 9.8. And then the only thing I know is then the sine of 100 over 27.4. So when you plug that in your calculator, so 9.8 times sine of 100 divided by 27.4, and then second sine that value, and you get what, 20.6? Did everybody get that in your calculator? So 20.6 is going to be the measure of angle A. Measure of angle B, I'm going to change colors here. So B is going to be North Carolina, or University of North Carolina, right? So angle B is just found by what? Saying what? 180 minus 100 minus what? That 20.6. Which is 59.4. So far so good? So far so good? Okay. All right, so what is the area of this region? Okay. So let's go back up to the triangle. What is the area of this region? So what do we have to find area? So area is 1/2 your base times your what? Your height. Okay. So do I know my base of my triangle? It really doesn't matter which angle you go from. I'll just tell you that, okay? So all three of these could be bases, right? All three of them could be our base. So it doesn't matter how we draw this triangle. And let's just go from this angle C that was given to us to find the height. I don't know what color y'all could see here. I'm going to draw it in red. Is that good? So the height would be this distance here. Yes, that would be my height. So do I know that distance to be able to find the area of this? I need to know it, but I don't know it, right? Okay. But is there now, hold on. I know what angle B and angle A are, right? Angle B was what? 20. What do we say? Angle B was 59.4. Oops. And then angle A was what? 20.6. Okay. So, is there a ratio where I can find that height? Because what is that going to create right there when I connect a 90-degree angle? Yes. So it's going to create this little 90-degree angle. Yes, right there. So is there a way for me to find my height? There are actually two different ways, yes. So I could say what? Okay, so we're finding the height. So that's a distance, right? So we're trying to find this distance. So let's think about our right triangle. So I know this angle. I'm looking for this side, and I know this side. So what is that side in my right triangle? So now we're looking at right triangles, right? So what is this side in the right triangle? What's it called? Hypotenuse, right? So this is your hypotenuse side. Yes, is 9.8. And right here, I know this angle, this 59.4, right? And I want to find the side that's what? Opposite. Yes. So what is opposite over hypotenuse? Sine. Good deal. So that would be sine. So to find the height, okay. So to find the height here, I would say sine of 59.4 is going to be equal to your height over 9.8. So your height of your triangle is going to be what? So 9.8, oops, 9.8 times sine of 59.4, which is what, 8.435? Let's just say 8.4. You all good with 8.4? So now I know my height, right? So I drew my triangle where the C is going to be my base, okay? So I drew that triangle to find the height where this is going to be my base. Does that make sense? Okay. I could have gone from right here. So if I went from right here and drew a right triangle, what would be my base then? The 23.9. Does that make sense? If I would have gone from this angle and did the same thing, then what would have been my base? The 9.8. Does that make sense? So I drew it where that 27.4 is going to be the base of my triangle. So now can I find the area? Of course. So I would say 1/2 my base, which is 27.4, times now my height, which I just found, right? So the area is going to be 1/2 your base, which was what, 27? So far up there, 27.4 times my height, which is an 8.4. So what do you get for your area? $115.1, roughly. Okay, what's my unit in here? Miles squared. Good deal. Square miles. Is everybody good with that? Does that make sense? Okay. Okay, so one important statistic about a region is its population density, or the number of people per square mile. So can I calculate the population density of this research triangle? Okay, what would I do? Perfect. So I'm going to take the amount of people, which in 2019 we had roughly 2 million, right? I'm going to take that 2 million and divide it by 115. Yes. Oop. I'm sorry. 2,079,687 divided by 115.1. Now what'd you get? I'm sorry. 18,068. Okay. And that's people per square mile, right? I guess that's not meters. I guess I need to do miles, MI, which is the right unit, yeah? Because we're not in meters. These are miles. Sorry. Okay. So let's think about this for just a second. Okay. So let's think about this for a minute or two. Okay, so this is the area when you don't have a right triangle. So how did I find my height here again? So I took sine, right? Sine of angle what? B. So to find my height, I took sine of angle B, right? And that was going to give me my height over this 9.8. But what is 9.8 equal to? What side is that? Side what? A. Okay. So this is my side A. So that's height over your A. Okay. Can I rearrange that formula? My height then would be equal to what? A times sine of angle B. Is that right? Okay. Now what was my base? So remember, this doesn't represent B in the triangle. It just represents your base of the triangle. So how we solved it, what was our base? What was the side? C. Okay. So if I were to use this area formula, it would be 1/2 side C times side A times sine of angle B. So that is our area formula when we are looking at an oblique triangle. Okay. And my sides could change for this. Does that make sense? So however I drew my height, my sides can actually change. Okay. So that means I know two sides and the included what? Angle. Do you see that? So I would know two sides and the included angle. Okay. Good. All right. So area of a oblique triangle when you are given side, angle, side. Okay, so side, angle, side. So let's kind of draw an oblique triangle here. Okay, so the area is going to be 1/2 base times your height. And your height is going to be given in the ratio of a side times sine of an angle. Okay. All right. So if I were given C and A, so side C and side A and angle B, then my area formula would be 1/2 your base, okay, is going to be your C times A times sine of angle B. You could also have it where it's 1/2. If you were given angle A here, then it would be C times B times sine of angle A. Or it would be 1/2 if you were given angle C. Okay, it would be your A times your B times sine of angle C. Good? Okay, so that's an oblique triangle. All right, there's another one when, because remember, because what would we use if we were solving for all the sides? We use, for side, angle, side, we use law of what? Cosines, good? So the other way to find the area of a triangle is when, what's the other way when you are using law of cosines? If you're given what? All the sides, right? So an area of an oblique triangle when you are given all of the sides is going to be a little bit different. Okay. We have to find something, it's called Heron's formula. Okay. We have to find something, a little s. And this is called the semi-perimeter. Okay, that means I'll add up all the sides and divide by 2. Okay. So semi-perimeter is all the sides added together divided by 2, but that's not my area formula yet. My area is then going to be the square root of the semi-perimeter times the semi-perimeter minus one of my sides times the semi-perimeter minus the other side times the semi-perimeter minus the last side. And that would be my area. Okay. So both of these two ways, if I were just trying to find all the pieces of my triangle, I would be using the law of cosines for this. Okay? All right, so take a minute and work through 1 through 4 for me. All right, let's look at number 1 there for finding the area of a triangle. So, do I have everything that I need to know to find the area? So, I either need side, included angle, side, or all 3 sides. So, do I have what I need to know?
Yes.
Okay, so we will say 1/2 times your base, which is whatever sides B, we'll say B, times B, times side C, and then multiplied by sine of angle A, which is 46 degrees. Okay, so when I plug that in my calculator, what do I get? I think I heard somebody say it, 25.9. Did everybody get that? So 25.9, and I don't know the units, so it's unitless, right? But area is always what? Squared. So we do need to just say maybe units squared. Good? All right, let's look at number 2. The fence around a triangular park measures 110 yards, 165 yards, and 200 yards. Okay, so what are we given here? So 110, 165, good deal. Side, 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 and 200. So if 1 acre equals 4,840 square yards, find the area of the park in acres. Okay, so first I need to find square yards, right? So if I'm given side, 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 what do I have to find? You could find the angle, but you don't have to. You don't have to waste your time doing that. So we are given the Heron's formula, yes. So we can find the semi-perimeter and then find our area from finding the semi-perimeter. So what is the semi-perimeter? So I would say 110 plus 165 plus 200, and then I would divide all that by 2. So what'd you get? 237.5, okay. Okay, so now we'll find the area by taking the square root of the semi-perimeter, which is 237.5, and then taking the semi-perimeter and subtracting it from each side measure. And then taking the square root of that. Because each one of these will be in yards, right? So it'll be yards to the 4th, and then you take the square root of yards to the 4th, which gives you a yard what? Squared. Okay, so let's look. So we'll say 237.5 times 237, 0.5 minus 110. And then times 237.5 minus 200 times 237.5 minus 165. I got a big huge number, and then we're going to take the square root of that. Let's see, I got 9,073.43. Did y'all all get that in your calculator? 9073.43 yards squared. Good. Okay. And then now I want to put it in acres. Okay. So it wants to take the area in terms of acres. So what am I going to do there with that value, 9073.43? I'm going to divide it by the acreage, right? So when I divide that by, 4840, I get what? 1.87 acres, roughly. Good. All right. I want y'all to finish number 3 and number 4 for me. And then we'll do those on Friday.